I'm Dave Saar, president of Saar Associates, Incorporated. Today we're going to be talking about the integration of an 800 or 900 megahertz radio module into an embedded system. This is the module that we'll be using for today's discussion. This radio can be configured for the 800 megahertz band for Europe and other parts of the world, or the 915 megahertz band for North America. The objective is to confirm regulatory compliance of the module, as well as confirm that the voltage and current going into the module are correct and that the digital commands are being correctly issued. We will use the Microchip Explorer 16 microcontroller board to control the RF module. We'll use the Tektronix MDO4000 to simultaneously and with time correlation monitor the current going into the module voltage, the digital control signals with the SPI bus decoded, and the RF signals coming out of the radio. We have here the microcontroller board that controls the radio module. The radio module is mounted to a carrier board. We have a voltage probe for the voltage going to the module, a current probe monitoring the current through the module, and a set of digital inputs that are monitoring the SPI bus. We can see the green trace shows the current at 20 milliamps per division. We can see an initial rise of the current as the module is turned on, and then the current goes even higher, in this case to about 200 milliamps, when the power amplifier of the module is turned on. We also show the voltage at a very fine scale to look for any drop in voltage, and here it's quite small. We also have the digital pins of the SPI bus shown and the decoded SPI bus. In the lower half of the screen we have the spectrum. One of the nice features of this product is that it can directly measure the occupied bandwidth and the total power in the band. Here we're showing about 97 kilohertz of occupied bandwidth. For this application and this set of rules, we need to be less than 100 kilohertz. One of the other features is that we can move the period during which the spectrum is taken. That period is shown by the orange bar in the time domain section. As we move it from the preamble, during which we see approximately equal amplitudes at the two frequencies of the frequency shift keyed signal, as we move across into the data section, we can see that in portions of the data, the low frequency predominates and there's very little of the high frequency. In fact, in this particular area, there's almost none of the higher frequency. We can scan through the data looking for any anomalies and be sure that the entire data packet is being carried correctly. In addition, we can look at the decode of the command set. What we do is zoom in on the SPI decoded signals. We're using the pan and zoom capabilities. And we can see that there's a burst of activity just before the start of the packet. By zooming in, we can actually decode the packet and see the hexadecimal codes that are initiating the packet transmission. What we have seen is the unique ability of the Tektronix MDO4000 series to capture in one trace the details of the RF signal, current, voltage, the digital control signals, and even provide the decode of those signals.